So we do often see parabolas in real-world problems. You'll see one later on has to do with football, basketball. Anytime you're throwing something in the air, it acts like a parabola. So that's why we see these often. So here we've got a parabolic microphone. They're so named because they use a parabolic dish to bounce sound waves toward a microphone placed at the focus. So the microphone is placed at the focus of the parabola in order to increase sensitivity. So the dish shown has a cross section with the equation x equals 32y squared, where x and y are in inches. So how far from the center of the dish should the microphone be placed? Well, remember it said the microphone should be placed at the focus. So if we take our equation, x equals 32y squared, we should know that the focus should deal with our 4p value, which means since p is 8, you should place it 8 inches away. So a reflective telescope uses a parabolic mirror to focus light rays. The focal length, so that's the distance to the focus, is 144 meters. And then the mirror has a 70 millimeter diameter, so the width here is 70 millimeters. What is the depth of the bowl of the mirror? So essentially then what we're looking for is how do we create the equation here? So the distance from the bottom of the mirror's bowl to the focus is p. So the vertex location is not specified, so we use 0, 0 for simplicity. The equation for the mirror is a horizontal parabola. So this distance is telling us to the focus, they're telling us it's 144 millimeters. That's telling us our p. Our p is 140 millimeters. So we also know that it opens right, which means it's going to be one of the ones with a y squared. So when we come up with our equation, our vertex we said was at 0, 0. We find the 4p. 4 times our 140 gives us our 4p value of 560. So our equation is y squared equals 560x. Since the diameter of the bowl of the mirror is 70 millimeters squared, the points on the rim have y values of 35 and negative 35. So essentially, this is what we're given here. We know that this value is 70. So that means we got value here at 35, value here at negative 35, so that total distance is 70. So the x value of either point will be the same as the x value of the point directly above the bottom of the bowl, and that's going to tell us the depth of the bowl. So since the points on the rim lie on the parabola, we use our equation to solve for the x values of either edge. So essentially we're plugging in one of these y values. So we're going to use positive 35 squared is equal to our 560x, which now we can use that to solve for x. So x should be 35 squared divided by 560, if I remember my 0 there. You can plug that into your calculator and you'll get approximately 2.19 millimeters deep. So a football team needs one more field goal to win the game. The goalpost that the ball must clear is 10 feet or approximately 3.3 yards off the ground. The path of the football after it's kicked for a 35-yard field goal is given by the equation they've listed there. So we're trying to check, does the team win? The key here is that this is given in yards. So what we're checking for, he's kicked a 35-yard field goal, and we know that the goalpost is 10 feet or 3.3 yards off the ground. So our height, when our x value is 35, because that's how long the kick is, it must be greater than or equal to 3.3, because remember our equation is in yards. So that's what we're checking for. So we plug in this x value into our equation. Y minus 11 equals negative 0.0125. X minus 220, sorry, and we're not using x, we're using 35. 35 minus 20 squared. Plugging that into your calculator, you should end up with negative 2.8125. So then when we add the 11 to the other side, We get 8.1875. So our question is this value greater than the 3.3 yards? Yes, it is. It's actually quite high. So he's got plenty of air so that he will indeed make the field goal, and their team does, in fact, win.